Good day and welcome. This time, let's have factoring polynomials using Rational Root Theorem. Rational Root Theorem. Suppose that a polynomial equation with integral coefficients has the root p over q, where p and q are relatively prime integers. Then p must be a factor of the constant term of the polynomial, and q must be a factor of the coefficient of the highest degree term. You will understand this theorem better once we go to our examples. Let me give you examples on how to solve for the given polynomials using rational root theorem. Here, we need the previous lesson about remainder theorem and synthetic division, which will play a very important role in determining the roots or zeros and the factors of the given polynomial. Example number 1, 4x squared plus 3x minus 1 is equal to 0. So we're going to solve this by using rational root theorem for us to find the roots and the factors of this polynomial. To start with, let us remember the theorem that any rational root must have a numerator that is a factor of -1. So this -1 will become the numerator and the denominator that is a factor of 4. So in this given, -1 stands for p and 4 stands for q. In the theorem, to get the roots or the possible roots, we have to divide p by q. Now let's see, it's already given here that the factors of -1 are +1 and -1. And the factors of 4 are positive -1, positive -2, and positive -4. The next thing that we're going to do is to find the possible roots. And how is that? We have to divide p by q. So again, factors of -1 will become p or the numerator, and factors of +4 are the denominators. So let's do it one by one. Positive -1 divided by positive -1 will still give us positive -1. Next, positive -1 divided by positive -2 will give us positive -1/2. And finally, positive -1 divided by positive -4 will give us positive -1/4. So again, it's p divided by q. That's why these are the results after dividing positive -1 by each of the factors here of 4. So these are the possible roots that we are looking for. And remember that not all possible rational roots are zeros. Meaning to say, these are not all the solutions to x of the given polynomial. That's why we have to move on to another step for us to get the real or the rational roots of the given polynomial. Now, let's have the continuation of number 1. 4x squared plus 3x minus 1 is equal to 0. In the previous slide, we've already determined the possible roots, and the possible roots are positive -1, positive -1/2, and positive -1/4. This time, let's find out which among these roots are the solutions or the real roots of the given polynomial. Let's have first positive negative, and let us use remainder theorem this time. So using remainder theorem, let us replace 1 with the value of x. So 4 times 1 squared plus 3 times 1 minus 1. Will this give us 0? Let's find out. 1 squared is 1 times 4, it's 4. Plus 3 times 1 is 3, copy minus 1. Is this equal to 0? Let's see, 4 plus 3 is 7 minus 1. The answer is 6. So it's not 0, therefore 1 is not a root. Now let's make it negative 1. So let me erase this and change positive 1 to negative 1. So we're done trying positive 1 and we found out that positive 1 is not a root. Now this time, let's have negative 1. Let me just put negative. Negative 1 squared is positive 1 times 4 is 4. 3 times negative 1 is negative 3, then copy negative 1. Is this 0? For minus 3 is 1, minus 1 is equal to 0. So therefore, negative 1 is a root of the given polynomial. Let me put S. We are expecting more roots to follow. Now, we're done with positive negative 1 and it's negative 1, which is a root. Now, let's proceed to positive negative 1 half. This time, let us use synthetic division for you to know that aside from remainder theorem, of course, you can still use synthetic division for us to determine whether the given number is a root or 0 of the given polynomial. So let's have 1 half. Let's have 1 half. Now 1 half as our divisor. Then let us list the coefficients for 3, negative 1. So bring down 4. 4 times 1 half is 2. Let's write 2 here. Then 3 plus 2 is 5. 5 times 1 half is 5 over 2. 1, negative 1 plus 5 over 2 obviously is not 0. So let us not write the answer anymore. Anyway, we're not looking for the remainder. We're just going to find out whether this will result to 0. And obviously, we'll not get 0 from here. Therefore, 1 half is not a factor. What about negative 1 half? So let's see. Let's use the same for 3, negative 1. Bring out 4. 4 times negative 1 half is negative 2. 3 minus 2 is 1. 1 times negative 1 half is negative 1 half. Negative 1 minus 1 half is negative 1 and 1 half. So again, this is not 0. Therefore, negative 1 half is not a root. So we're done with positive negative 1 half. And both are not roots. Now, we have the last choice, positive negative 1/4. But before that, let me erase the given here. Let's erase the given. And then, this time, let's try 1/4. Let's try 1/4 now. So, let us again use synthetic division. 1/4 here, and then 4, 3, negative 1. Bring out 4. 4 times 1/4 is 1. Write 1 here. 3 plus 1 is 4. 4 times 1/4 is positive 1. Negative 1 plus 1 is 0. So therefore, 1/4 is a root. So let us write 1/4 here. Now, let's have negative 1/4. Negative 1/4. So, negative 1/4. And then, let's copy 4, 3, negative 1. Bring down 4. 4 times negative 1/4 is negative 1. 3 minus 1 is 2. 2 times negative 1/4 is negative 1 half. So, obviously, this will not give us 0. Therefore, negative 1/4 is not a factor. Or, I mean, not a root. So, We're done trying all this, and it came out that only -1 and 1/4 are the roots of this given polynomial. And if we're going to write the factors of 4x squared plus 3x minus 1 are x plus 1 and x minus 1/4. So these are the factors of the given polynomial. So we're done. We're done solving for the roots, and there are two roots, and also the factors, x plus 1 and x minus 1/4. I hope this example is clear to you. Example number 2. The given is x cubed plus 2x squared minus 13x plus 10 is equal to 0. So we have to look for the roots or the values of x here. So let's have the factors of the constant term, and that represents p. And what is that p here? It's 10. It's the constant term. So it's 10. And let us list down the factors of 10. So we have 1, positive, -1. What else? Positive, -2, because we can divide 10 by 2. What else? Positive, -5. And finally, the number itself, positive, -10. So these are the factors of the constant term 10. Next, for Q, what are the factors of 1? So why is this 1? This 1 came from the number beside the leading coefficient. So the leading coefficient is the highest, the term with the highest exponent. And beside x cubed is 1. So that's why this is 1. So the factors of 1 are positive and -1. So no more. Only positive and -1. Next step, let us list down the possible roots. So possible roots. And how to get the possible roots? Simply divide p by q. So divide p by q. So let's say positive 1 divided by positive 1 is positive 1. -1 divided by positive 1 is -1. So meaning to say, when we divide positive -1 by positive -1, still our answer is positive -1. Next, to 1, we're done with 1. Let's have 2. 2 divided by 1, -2, and so on and so forth. So positive -2 yan. And the same thing for 5 and 10, we have positive -5 and positive -10. So meaning we have to divide p by q. Since we have 1 here in the denominator, it's also the same thing as the values for p. So the next step is for us to test all these possible roots one by one. We are not sure whether all of these are really the roots or the values of x for the given polynomial. So we have to use, we are now doing rational root theorem, but then we still need the previous theorem, which is remainder theorem. We can determine whether 1, 2, 5, and 10 are roots of the given using remainder theorem. So we have to check it one by one. So let's have first positive 1. Using the given is x cubed plus 2x squared minus 13x plus 10. So let's have first 1. So using 1, this will become 1 cubed plus 2 times 1 squared minus 13 times 1 plus 10. So if this will become 0, then positive 1 is a root or a factor of the given. So let's see. 1 cubed plus 2 times 1 squared. So this will 1 plus 2, that's 3, minus 13, that's -10, plus 10, 0. So it's 0 here, so therefore, 1 is a factor. So let me list here on the upper part. I mean, it's not factor. Ano yung correct term natin? It should be roots instead of factors. So let's have roots instead of factors. So we're done with 1. Wait. So we're done with 1. So how do we call it? Let's have the roots. So 1 is okay. Well, what do you think if negative 1? So let's have negative 1. Let's replace it with negative 1. And this one also negative 1. If this is negative 1, is it still 0? So let's see. So negative 1 cube is negative 1. 2 times negative 1. Negative 1 squared is positive 1. So 2 times positive 1 is positive 2. Negative 13 times negative 1 is positive 13. And finally, copy plus 10. Negative 1 plus 2 is positive 1 plus 13, 14 plus 10, 24. It's not 0, therefore negative 1 is not included. So negative 1 is not a root of the given polynomial. So we're done with positive negative 1. Then let's have positive and negative 2. So in other words, we have to test all the possible roots one by one, whether it will give us a result of 0. So let's have 2 this time, positive 2. So let me replace this with positive 2. Okay. So let's erase this one. Let's erase first. Wait. Okay. Let me now continue. So let's have positive 2. So this will be 2 cubed plus 2 times 2 squared minus 13 times 2 plus 10 is equal to 2 cubed is 8 plus 2 squared is 4. This is 4 times 2. So it's 8 again. Minus 13 times 2 is 26. And then plus 10. Will this give us 0? So 8 plus 8, 16. Minus 26. That's negative 10 plus 10. So it's 0. So therefore, positive 2 is a factor. So let's add here. Aside from 1, positive 2 is a factor. Next, let's have negative 2. But before that, let me erase again. Let me erase now the given. I have limited space here, so I have to erase. Let me erase positive 2. Okay. So, let's have negative 2 this time. So, x cubed, replace it with negative 2, quantity cube, plus 2 times negative 2 squared minus 13 times negative 2 plus 10 is equal to, is it 0? Negative 2 cubed is negative 8. Negative 2 squared is negative 4 times 2, that's negative 8 also. Negative 13 times negative 2 is positive 26 plus 10. Negative 8 minus 8 is negative 16 plus 26. That's positive 10 plus 10, 20. So, there is remainder, or remainder is not 0. Therefore, negative 2 is not a factor. So, we're done with positive and negative 2. Now, let's proceed to positive negative 5. So, first, let's replace x with positive 5. But before that, let me erase again. Erase here. What else? This one, let's erase. And, okay, sorry. Next, let's have positive 5. Replace x with 5. 5 cubed plus, let me copy 2. And then 5 squared minus 13 times 5 in close parentheses plus 10. 5 cubed is 125 plus 5 times 5, 25 times 2, that's 50. Minus 13 times 5, 75. Am I correct? 50, 65. It should be 65 here. So, 65 plus 10. So, let's see if we'll get 0 here. 125 plus 50 is 175. 175 minus 65, and then plus 10 will give us 120. So it's not 0. Therefore, positive 5 is not a factor. What about negative 5? Okay, let me erase again. Erase, erase here. Erase, erase. And then, let's change positive 5 here to negative 5. So, negative 5, negative 5, negative 5. So, negative 5 cubed is 125. Negative 125. The negative 5 squared here is 25 times 2 is 50. Negative 13 times negative 5 is positive 65, then copy plus 10. Negative 125 plus 50 is negative 75. Negative 75 plus 65 is negative 10 plus 10, 0. So therefore, negative 5 is a factor. So let's write here, negative 5 is a factor. So we're done with positive and negative 5. So let's be patient. All you need to do here is to be patient in solving. Now let's have positive 10. Last one. So positive 10. Let me erase all this. Erase and erase. This should be positive 10, positive 10. Okay. So, x cubed again. So, this will become positive 10 plus 2 times 10 squared minus 13 times 10 plus 10. 10 cubed here is 1,000 plus 10 squared is 100 times 2, so 200. 13, negative 13 times 10 is negative 130 plus 10. Now, let's solve if this will give us 0. So, mukhang it will not give us 0. 1,000 plus 200 is 1,200 minus 130, and plus 10 obviously will not give us 0. It's 1,080. So, therefore, positive 10 is not a factor of the given polynomial. And finally, let's have negative 10. So, let's erase all this. And then let's make 10 negative. So, let's have here negative 10 cubed plus 2 times negative 10 squared minus 13 times negative 10. Negative 10 cubed is negative 1,000. Negative 10 squared is positive 100 times 2, that's 200. Negative 13 times negative 10, positive 130. Positive 130, and finally plus 10. Will this give us 0? So negative 1,000 plus 200 is negative 800 plus 130, it's negative 670 plus 10. So the answer is negative 660. So obviously, it's not 0. Therefore, negative 10 is not a factor. Negative 10 and positive 10 are not factors. So we're done. Therefore, the roots of the given polynomial are 1, 2, and negative 5. And if you will be asked for the factors, so it's easy. The factors are x minus 1 from here, and another is x minus 2, and another one is x plus 5. So these are the factors. You have to put in the parentheses. But if you're asked to look for the roots only, so we have 3 also. 1, 2, and negative 5. So it's only one given. We have 3 factors, and we have 3 roots for the given polynomial. Now, example number 3, x cubed minus 4x squared minus x plus 4 is equal to 0. So, let's look for the factors, and the roots. What is the first thing to do? Let's have the given. The given constant is 4 and the given coefficient beside the highest term or the highest exponent is 1. So we need the factors of 4. So take note, it's P over Q. P stands for the constant, which is 4, and Q stands for the coefficient. So that's 1. Now, we have to look for the factors of each. The factors of 4 are positive, negative 1, positive, negative 2, and positive, negative 4. For the factors of 1, we have positive, negative 1. No more. So, we need to divide again. Since this is 1, obviously, these are the possible roots also. So, possible roots only, but not the actual roots. So, possible roots. Now, how do we look for the roots, the real roots, the rational roots? So, we have to do the same as what we did in number 2. So, we have to test all this, positive, negative 1, positive, negative 2, positive, negative 4. And it's up to you what method you want to use, whether synthetic division or remainder theorem. But for me, I prefer the remainder theorem. So let's have first positive 1. So let's replace this. 1 cubed minus 4 times 1 squared minus 1 plus 4. So we just replace the polynomial with the first possible root. Will it be equal to 0? So let's see. 1 cubed is 1. 1 squared is 1 times negative 4. That's negative 4. Negative times 1 or negative 1 times 1 is negative 1. Copy 4. Let's see if this will give us 0. Obviously, yes. So looking at this, so 1 minus 1 is 0. Negative 4 plus 4 is 0. So therefore, 1 is a root. 1 is a root of the given polynomial. Now, let's proceed to negative 2. So, let me erase this only. Then, let's replace 1 with negative 1. So, let me just put negative here, and negative here. Negative 1 cubed is negative 1. Negative 1 squared is positive 1 times negative 4 outside, that's negative 4. Negative 1 times negative 1, that's positive 1, and then copy 4. So again, we can see that the result here is 0. So look, negative 1 plus 1 will give us 0. Negative 4 plus 4 will also give us 0. So therefore, negative 1 is also a root. So we're done with positive and negative 1. Let's proceed to positive negative 2. So let me erase this part. And the number inside the parentheses. And let me change it to positive 2. So let's have now positive 2. So positive 2 here, positive 2, positive 2. 2 cubed is 8. 2 squared is 4 times negative 4, that's negative 16. Negative 1 times 2 is negative 2, and then copy 4. 8 minus 16, that's negative 8 minus 2 plus 4. Let's see if this will give us 0. Negative 8 minus 2 is negative 10 plus 4, obviously is not 0. So therefore, 2 is not a factor. Or 2 is not a root or 0. Now, let's erase and replace 2 here with negative 2. Or simply, let's put negative later. So, let me erase all this. Erase. Okay, there. Let me just put negative beside 2. So, we are now solving for negative 2, whether it will be root of the given polynomial. Negative 2 cubed is negative 8. Negative 2 squared is negative 4 times negative 4, positive 16. Negative 1 times negative 2 is positive 2, then copy plus 4. Negative 8 plus 8, negative 8 plus 16 is positive 8, plus 2 plus 4 obviously is not 0. So this is 14. So negative 2 is not a factor. We're done with positive negative 2. So let's cancel this. 1, 2, and negative 2 are not factors. And finally, let's sub 4. So let's erase this. Let's erase this. And let us change the values of x to 4. Change now to 4 and find out whether it will give us 0. So let's have 4. Let's have 4 here. 4, 4. 4 cube is, what is 4 cube? I think it's 64. 4 times 4 times 4. Yes, it's 64. 64. And then 4 squared is 16. Times 4 again, times negative 4, that's negative 64. And then minus 4 plus 4. So I think we can get 0 here. 64 minus 64 is 0, negative 4 plus 4 is 0. So therefore, 4, positive 4 is a factor. So let's include 4 in the list of roots. So roots now. And finally, let's have negative 4. But before that, let me erase all this and then change all 4 into negative. So this will be negative 4, negative 4, negative 4. Negative 4 cubed is negative 64. Negative 4 squared is positive 16 times negative 4 is negative 64. Negative 1 times negative 4 is positive 4 plus 4. So here we can cancel. Oh no, we cannot cancel because it's also negative. So obviously it will not give us 0, negative, negative. We have to add this. So this will be negative 128 plus positive 2, positive 4 plus 4, that's 8 also. So negative 128 plus 8 is negative 120. So it's not 0. Therefore, negative 4 is not a is not a root. So finally, we have now the following. 1, negative 1, and 4 are the roots of the given polynomial. That's all for now about the examples on how to find the factors and roots or zeros of the given polynomial using rational root theorem. Thank you and have a blessed day.